start layer where we're randomly assigning the cells to be alive or dead. Well, that's good that we're updating there, but actually what we want to do is to build some sort of a stack in 3 dimensions. And we want that stack to sort of save the layers, okay? And that's why we're actually not updating, because we need to save whatever we're doing. So I'm gonna actually go and start to add a few more things in our world. So we don't really want to be in a 2D world. We want to sort of be in a 3D world, right? Because seeing those cells play on the ground is not very architectural. It is interesting as a behavior, but it's not very architectural. We can't imagine anything out of it. So we're going to also make another variable. And this one is going to be an integer. And we can call this height. So I know I want to build a stack out of these layers, right? So each frame, I'm going to compute a new layer that's based on the interaction of the cells, and I'm going to save it above, and then another above, and another above, and another above, and so on. And every time I'm starting from the layer below, right? So every layer starts by having the layer below as what's computed before. And this will give me, think of it as a history almost. So if you had a 3D printer, right? Think something like this. If I have a 3D printer and the nozzle goes, it will sort of print the stack. But the printing of the stack will be based on the relationship between the cells. So that's quite interesting. Right. So because now we have that stack, we also need to create an array that saves the stack itself. So, and I think let's make it in here. And it's a bunch of game objects, and this is 3-dimensional, right? Because it has multiple, it has X, Y, Z in a way. And we can call this the stack. All right. And I want to actually start also to think of analysis. So my first analysis is going to be maybe how many cells I have in the stack, how many alive cells I have, which again, some interesting variable to have. And I'm gonna set it to 0. This actually stays the same. Okay, I'm gonna do this a bit later on using a user interface, which we can make it a bit more interesting. But for now, in the start function, we also need to initialize the stack itself, right? So the stack is going to be new game object array, and this one takes in the columns, then it takes in the rows, and it takes in the height, right? So it's a 3-dimensional array. All right, I think with that, I won't yet do this. So update stays pretty much the same. I have my update, but I need to sort of go and compute a bit differently. So what I'm gonna do, instead of just updating the layer, I'm gonna ask what's the height of my stack. And I know I have that current height value that I set in the beginning, and I'm going to ask if it's smaller than the actual height that the total stack can have. So we're going to grow this stack layer by layer until we get to a certain height, and then we stop. Okay? Now, the first step is going to be to display the current one, so the one that we're computing. And we need to compute the future state of the layer that's going to be added on top, right? Okay. So for this, the first step is to actually save to update the layer, right? So I have this function already built. So after I've updated the layer, I actually need to save the layer, right? So I need to save it to the stack. So I'm gonna have this save layer function, which obviously for now is throwing me an error because it doesn't exist. Then because I've created the new layer, I will need to update the height, right? And after I've done my height, I will probably need to update the ones that are alive. And again, it's going to give me an error because these don't exist as functions. So that's fine. I have here my create layer. I have in here my update layer. So what I need now, and for the sake of making things a bit more manageable, I'm going to collapse this. So here I have this is a function to create the initial. And we're also going to do something interesting. The initial layer now we're generating with the random. We're going to use a seed image. So we don't really want the beginning to be random. We would like to control a bit the pattern. So we're going to use a seed image a bit later on. But let's not get ahead of ourselves. All right. So that I have. Okay, so let's go and make our save layer function. So how does the save layer function work? Well, it's quite a basic function. What we're going to do, we're going to go through the current layer, the one that we've computed, and we're going to add it to the stack. Okay? That's very simple. And because we're creating a new, like essentially think of an active layer that always exists there, right? Which is your cellular automata. And then in the stack, we're going to create a bunch of cubes, which are copies of the current state, right? So I need to make a new game object. So I need to make a new layer that is going to save the computed cells. And first, we need to give it a name. So this is going to be the layer name. And well, obviously it's called the layer. So that's the first part. And then we're going to add to this the current height, which is an integer that we're counting. So at what height we are. And because that's an integer, I need to convert it to a string. So I can concatenate. So it's going to be layer, and then it's going to be layer 0, layer 1, layer 2, layer 3, layer 4, up to my maximum, which in this case, I think I set it as 40. Okay? So that's the first thing. I need to make this layer name. Then I need to actually make a game object that is going to save this. So it's going to be called current layer. And this is just going to be a new game object. And the parameters we're going to use in here is the layer name. So we want to actually name it something. And actually, it's quite interesting to remember, I'm telling you to, as you go with the code, try to learn the code by just looking at what is happening. So when you make a new object, you can just use the new game object without any parameters. And this creates a new game object named name. So without a name. Then you can pass in a string name, okay, which actually will create the new game object with a custom name. And you can also make it with a name, and also you can add some parameters. And this is a bit more advanced. Maybe we'll get there, but for now, we're going to use this layer name that we just made. So that's fine. We've created the current layer, but I think the current layer would be nice if it's attached to the grid, right? Because we have a grid, and you can think of it as a 3D grid, right? So we wanted that this new layer becomes a child of the grid, okay? So we're gonna get the current layer. From the current layer, we need the transform, and this is going to be the child. So for the transform, I need to set who is the parent, and the parent is this script, right? The game object and the transform, right? So think of this. So I've created a new game object. I set the name of that new game object as being layer name plus a number. Then I set this to be a child of the grid. Okay? So that's nice. And now we actually need to copy the cells themselves, right? So copy the current cells to the new layer. All right. This part by now you should be fairly familiar with. So we need two loops. One that goes from I to columns. I starts at 0. And then we need another for loop that counts from 0 and it goes to the number of rows. Okay, so now we need to get the cell that we have computed. So game object computed cell is going to be our layer. Right, so we're getting from the computing layer. So remember, there's always one layer that computes, which we're gonna keep at the bottom. So that is the one that goes and plays the relationship, and that's the bottom. Okay. All right. So now we're gonna say something similar to this. We're going to say that well, we need the position of this guy. So the computed cell position is going to be a new vector 3. And in here, what parameters we're going to use? Well, we know we want it to be at I times spacing. Then now in here, when it comes to the height position, the Y value, here we need to use the current height, right? And we're going to multiply that by spacing as well. And then we need J, and we multiply that by spacing as well. Okay? So remember when we're creating the layer, the initial layer, we're setting the position to 0. So in the Y value, we're having 0 in here. But we want these layers to go into the stack up and up and up and up. So every time we increase the current height value, the new layer that we're computing is getting saved a bit higher up, and then the next one a bit higher up, and so on. Right. Then we know we also need a quaternion. And this one we can call computed cell rotation, I guess. Yeah. And for this one, we're going to just use the identity quaternion, which is unrotated. All right. Now, we need the state of this particular cell. So that's an integer. So how do we get this? Well, we need to get the computed cell itself. From the computed cell, we need to get the component that actually has the value of the state. And we know that one is the cell component, right? And from that, we need to get the state, right? And just a reminder, in the cell, So that's the cell component. We have a function in here that goes and gets us the state, right? No, that's the set state. Where the hell? It is somewhere in here. Set computed, display cell, display age. Where is it? Okay, so we have this very simple function get state that returns the state. All right. All right. So we've got the cell state. Okay. Now we pretty much need to copy it. So we're gonna make a new game object, which is called copied cell, and this guy is going to be instantiated. And what do we need to instantiate? Well, the cell prefab. Where do we instantiate it? Well, we will put it at the computed cell position, and using the computed cell rotation. Okay. So that will sort out the that will sort out this part. Okay, so now that we have the new cell, we need to set its actual state, because remember, this one will stop computing. So for the copied cell, again, we get the component, and the component we get is the cell component. And for this one, we're gonna set the state. Okay, and this is going to be the computed cell state. Okay, so that's the first part. We set the state for this one. Then we need to set that is computed, right? And again, copied cell, we get the cell component. And here we need to set computed as being true. So this has been computed, so there is no need to compute in the future. And also we should copy the age. So for this one, we're gonna get component, and the type of component we need is the cell component. And from this one, we get the age. And this is going to be equal to the computed cell. Get component, type cell. Okay, and we need the actual age from that one too. Boom. And we're almost done. We need our copied cell to make it a child of the new layer we created. So we get the transform. Then we are saying that the parent is going to be the current layer. And from that layer, we need a transform. And the last part is to actually save it in the stack. So for the stack, I, j, it's actually I, j, and then current height. Okay, it's going to be copied cell. Okay, this is quite a long script. So I will do something. How can I send something through Zoom on the chat? Let's do the update alive, and then I'm gonna send you the script so you can get it as well, because I'm pretty sure you might have missed some of the things I'm typing, which is fine. Like, I don't expect it to type along. Okay, so now I have this new method, which is the save layer method. I can collapse. So I need one more function, which is in truth an analysis function. And let's call this computation. These are computation methods, and these are analysis methods. And this one is the update alive. Boom. This is a very, very simple function. We're gonna need to have 3 for loops. One that starts at 0 and goes to number of columns. Am I doing columns and rows, and am I doing the other way around? Yeah, so I'm doing columns first. Fine. Oh, but then in here maybe, I don't know, I did the same, columns and then rows. Just make sure you're consistent. So if you're starting with columns, keep columns first. I need another one that comes from 0. J will be smaller than rows. J plus plus. And then in here, semicolon. And we need another one. This is the first time we're gonna go in 3 dimensions. So we need another for loop. And this time we can use K and starts at 0. And well, I guess K needs to be smaller than the height. And actually it should be smaller than the current height. Yes. So K should be smaller than current height. And then we need to get the current cell in the stack. And from the stack, we need I, j, k. Okay? And then we're gonna ask something very basic. If current stack cell get components, and the component we need is the cell component, right? And from the cell component, we're gonna ask what's the state, and if that state is equal to 1, then we're gonna increase the number of alive cells. Okay. Okay, I think now I have everything I need in here. So let's collapse this as well to look a bit at what we have in here. So we have 4 functions: creates a start layer, update layer, save layer, and update alive. And in our start function, we call the create layer, and we create a new stack. So create new stack, and here create the initial or the first layer. Okay, then in the update, we compute the CA. So we're asking if the height is smaller, the current height is smaller than the current height. We display the current layer and compute the future states for the next layer. Okay, and then we save the current layer to the stack. Okay. And in here, we make some analysis. Okay, so think of this as steps. And I think instead of display, we can call this compute future states. So first step, compute that. Step 2, save the current layer. And then step 3, get some information. Okay, and think of something like this. You're always going to do something clever in this step. And obviously, we can create some other steps as well. So we could have step 4, do something clever with the stack. Okay? Right. So I think for me, the most important thing is for you to understand the computational model, to understand how this works. Okay? So let's go into our cell. I hope this one is also fairly well explained. Maybe at some point we will do the same. Okay. Well, let's see if it works, because it's always boring to look at. So let's do something that it's a bit more slender. So we can do maybe 15 height, and let's do 20 and 20 in this. Okay, so let's have a look at this. I think they're gonna explode. I need to put them a bit further apart. Yeah, it's amazing. Boom. Do you guys know why that happens? Anyone? Any idea why they explode? Exactly. So if you look at our prefab, the cell has on top of it a box collider and a rigid body. So what's happening? Because they're almost touching, and if we look at the prefab itself, you see there's this almost green line. So that's our box collider. And when you get two cells that are touching, they're gonna push each other out. Okay? But that's easy to fix. So in my grid, I'm gonna space them 1.2, which should fix that. Ah, come on. Are they still collapsing? Okay, let's see why. I'm gonna turn off the box collider for a second because I don't want these guys to explode. We'll make it work a bit later. There we go. We now have a nice stack. Well, not the most interesting stack, but we do have a nice stack. Should we make the physics work? Because I think it's fun if we could actually, if we could actually make them explode or something. But there we go. We now have a way of computing things. And I was also telling you, like, I think it's okay to start with random, but honestly, let's do something a bit more clever. So instead of starting with a random seed, let's use some image that we can decide in the first layer where we place the cells. Okay? So how do we do that? Well, we're gonna have to change a bit um, our CA in here. So I think setting up the grid, we'll use an image. Um, yeah, let's see the image. So let's go in here. In here, we're gonna use a public texture, and this is a 2D texture. And I think for these, let's go into Photoshop. And let's try to make some interesting seeds. Okay, so I'm going to create a new seed image. And we know our stack starts 20 by 20, right? So that's our stack. It has 20 pixels by 20 pixels. Okay, not very big. So it's a tiny little texture. And I'm gonna get the brush, and I'm gonna set my brush to 1 pixel. So with this, I can sort of decide that maybe I want my cells to be placed in a diagonal. And I guess let's make it a bit more interesting. So I can create my initial seed to look something like this. And I guess, I don't know, I'm gonna also make it so it goes. Right, so that's gonna be my seed image. Let's go, I guess. And in reality, I've done it wrong because I should have used this is a soft brush, right? And I should have used a hard brush. Where are my brushes? That's funny. So I want a hard brush. It should have been, oops. Mm, mm. Okay, so I'm gonna use a hard brush. Oh, come on. Didn't I set it as a hard brush? Well, anyway, this will work too. But I would have liked to have only black, no gray, but this works too. right, so let's go and save this as my seed image. Okay, so I'm gonna go now into Unity. Let's make a new folder. Or let's call these seed images, no? And in here, I'm gonna import my newly created seed image. Now, very, very important. And it's a shame I'm not recording this because this actually is very important. We need to change the texture type from default. We need to change it to a sprite. So you see, it tells you that this is 2D and user interface. That's the first step. Now, there is another one, which is to enable reading and writing from the texture. Otherwise, we won't be able to read the data on the texture. Okay, so now that we've changed this is a sprite, a 2D texture that I can read and write from. Okay, I can actually use this. So if I go into my grid, you see here that it says you need the seed image and it needs to be a texture 2D. Well, I can now plug it in. Otherwise, if it didn't change it to UI, it wouldn't allow me to. So, okay, I've plugged in my seed image. Now let's go to Visual Studio. And in here, in our create initial layer, remember we were doing here a random range? Well, we're gonna change this part. So for this, we're gonna use the seed image. And from here, we're gonna get, I think we want pixel data, but let me check. I don't remember what I was doing. I think I was getting, yeah, get pixel and then the grayscale value. All right, so let's switch to that. Come on, hide. This is so annoying. So the pixel we want is at I, j, and we want that the grayscale value. Now this is gonna complain that the grayscale value is in a float, and I need the integer. So what we need to do, and this is called casting, we're gonna change from a float to an integer. And the way you do that, you put in front of the value what you're casting, what you're going to change towards. Okay? Cool. So now, instead of using random, we can plug in our seed image. Oh, come on. Bloody thing. Oh, no. All right, so now because we're using the seed image, our initial grid should look a bit different. And funny enough, it does, but it's not as different as I was hoping for. And there's also something is not right. Where are my layers? Layers are saved here, nice and fine. Okay, so I can see that my layers are saving correctly. Whoa. Okay, I think that works. It's not very interesting what what I've made as an initial seed image, but hey. And actually, at the end, we should delete the cells that we're using for computing. So once we're done, I think we should just go and delete these guys. These ones, remember, they're used for computing. So we kind of need them to delete them. So let's maybe do that as well. So let's do in our code, in update, after we finish computing the CA, we need to delete the, so when the current height is bigger than the height, we're gonna go and destroy all the cells that we're using final step. We're gonna destroy the cells that we use for computing the CA. And I think should we do it with the function? Well, we could do it with the function, but to be honest, we know what we need to do. So this goes from I equals 0, I smaller than columns, I plus plus. Then we need another one, j equals to 0, not j value, j smaller than rows, j plus plus, and not j value. Okay, so what we need here, we need to go layer I comma j. Remember, so the layer is the initial layer. And probably we should have called this, instead of layer, we should have called this the compute layer. And we know in going here, we can use destroy. Okay, so when we use the destroy function, is actually is asking you what is the object. Okay, so for this one is layer I comma j. Okay, let's go into Unity. I'm gonna make my grid a bit smaller, maybe 30. Okay. And I should also set up my camera a bit more interesting. So my grid now starts in the center, but I know he's gonna grow from that point into this direction. So I think I should move him by the amount of columns there, so maybe 20, right? And I should probably move him also in this, also 20. So basically, when I finish, and actually, let's put it in the center. So let's do 10 and 10, right? So then when it gets created in the center of my camera, right? What? Still not in the center? I guess this should have been 20. Let's see. Ah, yeah, because we're doing in a for loop, so it doesn't actually matter. Okay, so you see now it's correctly computed. I have my layers. and I got rid of the compute layer. And I'm basing this on the actual seed image. So let's have a look to understand the business stack. So I'm going to get these other layers, and for now, I'm going to turn them off. So I have my original layer, and that's super interesting. You see how it relates to our Photoshop file, and that's what I was saying here, that it actually matters how you draw this. So let's make a new one, and this one we're gonna fill with black, and I'm gonna switch to white and get the brush, and this time let's make sure that we're using the hard brush. So this time let's do it the other way around. So we're gonna start, let's go to maybe half here and then something like that. Okay, and let's make something interesting. So let's say a zone somewhere here also gets, for some reason, we want it like this. So let's save as. So this is set image 2. And in here, let's import a new texture. And similarly, it has to be a sprite. And we need to enable read and write. Okay, cool. So let's see how that stack will look. So we're gonna swap the seed image. And this one, let's call this the stack instead of the grid because it's a grid. And I think I'm gonna also play a bit with my camera. So let's move it slightly. A bit down. And no, that's the player. Player position. This looks slightly more interesting as a stack. No? So now you can see how it went from our initial seed. And it looks like it kind of got the line, but it didn't get the diagonals really well. Right? Or is someone texting? Ah, okay. Okay, cool. I think let's maybe stop here. I'll pass the code to you. And what I want you to do as a homework is to produce shit tons of seed images and play with different patterns. And also in the stack, I want you to start changing these values, okay? Cool. Sounds like a good plan. I'm gonna export the package. Yeah, get everything from here. All right. I want to hear a bit from you a bit. How do I do quickly? Stop sharing. How do you find about what we're doing? Is it so far understandable? Um, do you think you can? Not do you think? So for next time, we'll start a bit differently. So we're gonna start our section, and you are divided in teams now, right? Let's ask a person who's very silent. You shall, Ren?
Yeah.
Yeah. So, okay, you are divided in teams, right? You've chosen your teams. You've made already your groups of 4, right?
Yeah.
Okay, so I think the homework will be something like this. And how many teams we have? 5 or 4? 4 teams. Okay, so then let's see something like this. Team 1 is going to look at patterns that are based on lines. Something. So team 1 is going to do only lines. So you can only, you're allowed to only draw lines. And they are not connected. They need to be drawn whatever. Then team 2 can only do interesting patterns using diagonals. Okay. Then team 3 can do, I guess, circles. And team 4 can do whatever they want. So I want to see next time, and you have to show, we're going to do a show and tell. So each one is going to do at minimum 10 patterns and create 10 stacks. So you have to put in a PowerPoint the 10 stacks, and you need to show us what is your initial seed image and what is the final output of the stack. Okay?
Okay. You mean before Monday? We will present the PowerPoint in Monday.
Exactly.
Okay.
It's not a lot. You have to draw 10 images and community save them.
Yeah.
And up to you. You can pimp up this scene to make it more looking nicer and whatever. But what I want to see is what's the seed image and what is the output. Okay? And to keep it consistent, the stack should only always be, let's do 20 by 20 by 40 maybe. Okay, so always is the same amount. Okay.
Okay.
Cool. Okay, everyone. Well, I'll see you on Monday, and yeah, enjoy your seed image drawing exercise. Okay.
Thank you.
Cool. Okay, everyone. Thank you.
Thank you.